Sathyabama Institute of Science and Technology.
Hi, vibrant learners. Wish you all a blessed day from Dr. A. Viji Amutha, Professor, Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. So, today we are going to learn an interesting algorithm and we are going to do the time complexity analysis of the same. So, let's go into the video. Today we are going to discuss the linear search algorithm and we are going to analyze the time complexity of the algorithm. So the algorithm is given here. So the algorithm takes three parameters. A is the array and n is the number of elements and x is the element to be searched in the given array. Okay. So we use a for loop for int I equal to 0, I less than n, that is the condition given. So I is incremented. So within the for loop, we just compare each and every element in the array to the element x. So if the element x is equal to the element found in the array, then the index position of that element will be returned. That is I. I is the index position of that element. Otherwise, if the element is not found in the array, okay, then -1 will be returned, stating that it is false. Okay, indicating that it is false. Once again, let me explain the algorithm. Each and every element in the array is compared with the element x. If the element matches, then the index position of the element will be returned. Otherwise, a value -1 will be returned, indicating that the element is not found in the array. So now we are going to analyze the algorithm with the three cases, that is worst case, best case and average case. So what is that worst case? First let us see the worst case. So when does this worst case happen? When the element is not present in the array or when the element is found at the last position in the array, then the worst case happens. So you need to compare all the n elements in the array and then only you come to the conclusion that the element is found in the last position or the element is not found in the array. So here the upper bound on running time of an algorithm is calculated. So in this worst case, maximum number of operations are to be executed. So as I told you before, if there are n elements in the array, you need to compare all the n elements. Then only you can come to a conclusion that the element is present at the last position or the element is not found in the array. So the algorithm compares the given element with all the elements of the array one by one. So the worst case time complexity of linear search algorithm is given by big O of n. So since you need to compare all the n elements of the array, the time complexity is given as n. So it is a linear time complexity, okay, which is denoted by big O of n. So usually the worst case time complexity is denoted by big O. So the next comes the best case analysis of linear search. So the best case occurs when the element is found at the very first position. So at the very first search, at the first search itself, you find the element. Here the minimum number of operations are to be executed in the case of best case. And here we calculate the lower bound on running time of an algorithm. So the number of operations in the best case is constant. It is not dependent on n because you compare the very first element in the array with the element x and it matches. So that is the best case. So the time complexity of linear search, that is the best case time complexity of linear search, is given by omega of 1. It is a constant time complexity. Okay, so here you compare only one element in the array and that matches. Okay, so the best case is denoted by omega. So time complexity, the best case time complexity of linear search algorithm is big omega of 1. So the next is the average case analysis. Actually, average case analysis is little bit difficult compared to worst case and best case analysis. Okay, let us solve it. So it gives information about the behavior of an algorithm on a random input. So to solve this, to find the average case analysis of linear search, so let us take P as the probability of getting successful search and let N be the total number of elements in the list. So the probability of occurring first match of an element is P by N, that is actually P into 1 by N. Okay, so the probability of getting unsuccessful search is written as 1 minus P. So let us find the average case time complexity of linear search now. Usually the average case time complexity is denoted as theta. So theta of n will be equal to probability of successful search plus probability of unsuccessful search. So theta of n is given as 1 into p by n plus 2 into p by n, or in other words you can say as p into 1 by n plus p into 2 by n and so on up to p into n by n. So this is the probability of getting successful search, plus you are adding it with the probability of getting unsuccessful search. So when do you get that unsuccessful search? So that is denoted by 1 minus p, and you need to compare all the n elements for unsuccessful search. So we are writing as n into 1 minus p. So the first term, that is in the first term, you can take p by n as common. So when you take the common term outside, that is p by n, and you write the remaining terms inside, that is 1 plus 2 plus 3 up to n, plus write the probability of getting unsuccessful search, that is n into 1 minus p. So in the third equation, we get as p by n into, so it is the sum of natural numbers 1 plus 2 plus 3 up to n. So the formula for the same is n into n plus 1 by 2. Write that formula, n into n plus 1 by 2 plus n into 1 minus p. So here you can cancel the n terms. So you get, in the fourth equation you get p into n plus 1 by 2 plus n into 1 minus p. So this will be the general formula for computing the average case time complexity of linear search algorithm. So now you substitute p equal to 0. So if there is no successful search, that is for unsuccessful search, you substitute p equal to 0 in the general formula. So when you substitute p equal to 0, the equation becomes, so wherever p comes, you just substitute as 0. So 0 into n plus 1 by 2 plus n into 1 minus 0. So the first term becomes 0 and you get only the second term, that is n. So theta of n equal to n. When you substitute p equal to 0 in the general formula, you get the final solution as theta of n equal to n. Okay, now if it is a successful search, substitute p equal to 1. Okay, in the general formula, just substitute p equal to 1. So theta of n equal to, so instead of p we are substituting 1. So 1 into n plus 1 by 2 plus n into 1 minus 1. So here the second term becomes 0 and you get the first term. So the first term is n plus 1 by 2. So by ignoring the non-dominant terms, we get the value as n. So here also we get the value as n. So thus we come to a conclusion like the algorithm scans about half of the elements from the list, and this is the average case complexity. So hope you have understood the time complexity analysis of linear search. Thank you learners for listening the video very patiently. Meet you again in the next video lecture. Thank you once again.